Good morning, students. Myself Swati Shabnam, Assistant Professor, Department of Agronomy, Birsa Agricultural University. The course title is Farming System and Sustainable Agriculture for BSc AG 4th semester. And today we will talk about sustainable agriculture. Now, sustainability is the most talked about term these days. We talk about sustainable production, sustainable growth, sustainable development. So, what exactly is sustainability? The word sustainability means to maintain anything at a certain level, anything at any level. So that's why sustainability is the important thing in agriculture also. And if we talk about agriculture, it is the first responsibility of any civilized society to provide sufficient food to all the people, and especially the people living below poverty line. So right now world population today is 7.79 billion to be exact, and is estimated to become over 8 billion by 2025, around 9 billion by 2050, and more than 10 billion by the end of this century. So this will require a 70 to 100% increase in food production. In simple terms, the production needs to be doubled. And not only this, several studies indicate that agriculture production could be significantly affected by rising temperature, changes in rainfall, variation in frequency and intensity of extreme climatic events such as floods and drought, all in accordance with climate change. And crop yields have already experienced negative impacts. It is estimated that crop production loss in India by 2100 can be 10 to 40% despite the beneficial effects of higher carbon dioxide concentration on crop growth. With every rise of 1 degree centigrade temperature, 4 to 5 million tons of wheat can be lost in, especially in tropics. And globally, climate change is expected to reduce cereal production by 1% to 7% by 2060. The yield loss can be up to 35% for rice, like 20% for wheat and all. At least 22% of the cultivated area under the world's most important crops is projected to experience negative impacts from climate change by 2050. And not only is agriculture under pressure of feeding more and more people, but being a driver of climate change is also under tremendous pressure of reducing its share in it. With increasing dependency over fossil fuel based industries and farm mechanization, especially in modern agriculture technologies, as well as deforestation for agricultural land, for increasing agricultural production and all other agricultural activities, contribution of agriculture sector to all anthropogenic greenhouse gas emissions responsible for global warming is estimated between 14 to 18%, as analyzed by World Resource Institute and UNFAO. So now, before coming to sustainable agriculture, we should understand the agriculture scenario in India. The agriculture scenario in India can be divided into three parts. First one is before mid-60s, which was when low input and low productivity technologies were being used, and subsistence agriculture was followed, where farmers were able to produce just sufficient for themselves and there was not enough food for the people in country. Then came the Green Revolution era from mid 1960s to 2000, where high input and high productivity technologies were adapted, and as a result there was a tremendous enhancement in production to meet the food grain demand of fast escalating population. But after 2000, in spite of using the high production technologies of modern agriculture, the output was declining, and the main characteristics were stagnation in food grain production, shrinking in operational holding, decline in total factor productivity, increasing cost of production, low resource use efficiency and reduced farm household income, high use of chemicals, agrochemicals, environmental quality concern and contract farming. And then came the need for sustainable agriculture. Modern agriculture, the problems with modern agriculture is that modern agriculture begins on the research station where researchers have all the access to necessary inputs like fertilizers, pesticides and labor at all the time when needed. But when package is extended to farmers, even the best performing farms otherwise cannot match the yield the researchers get. For high productivity per hectare, farmers need access to the whole package. Modern seeds, high yielding varieties of seed, water at appropriate time, labor, capital or credit, fertilizers and pesticides. But many poor farming households simply cannot adopt the whole packages, and even if farmers want to use the external resources, very often delivery systems are unable to supply them on time. If one element is missing, like the seed delivery system fails or the fertilizer arrives late or there is insufficient irrigation water, then yields may not be much better than those for traditional varieties. Where production has been improved through these production technologies, modern agricultural technologies, all too often there have been adverse environmental and social impacts in both the advanced and developing countries, including India. Now, the adverse effects of modern high input agriculture can be listed as overuse of natural resources causing depletion of groundwater and loss of forests, wild habitats and of their capacity to absorb water causing waterlogging and increased salinity. Contamination of atmosphere by ammonia, nitrous oxide, methane and the products of burning which play a role in ozone depletion, global warming and atmospheric pollution. Contamination of food and fodder by residues of pesticides, nitrates and antibiotics. Contamination of water by pesticides, nitrates, soil and livestock water causing harm to wildlife, disruption of ecosystems and possible health problems in drinking water. Build-up of resistance to pesticides in pests and diseases including herbicide resistance in weeds. Damage of farm and natural resources by pesticides causing harm to farm workers and public, disruption of ecosystems and harm to whole wildlife. Erosion of genetic diversity, which is the most important problem. The tendency in agriculture to standardize and specialize by focusing on modern varieties causes displacement of traditional varieties and breeds which are otherwise very important for the genetic diversity. New health hazards for workers in the agrochemical and food processing industries. Added to the above adverse effects, the increasing human as well as cattle population is imposing intense pressure on available natural resources, as we discussed earlier that the world population, global population is increasing at an alarming rate. Now coming to the definition of sustainable agriculture, according to 1990 US Farm Bill, integrated system of plant and animal production practices having a site-specific application that will over the long term satisfy human food and fiber needs, enhance environmental quality, make efficient use of non-renewable resources and on-farm resources and integrate appropriate natural biological cycles and controls. Sustain the economic viability of farm operations and enhance the quality of life for farmers and society as a whole. Now, according to Reganold et al. 1990, sustainable agriculture can be defined as, for a farm to be sustainable, it must produce adequate amounts of high quality food, protect its resources and be both environmentally safe and profitable. Profitability is the most important thing. Instead of depending on purchased materials such as fertilizers, a sustainable farm relies as much as possible on beneficial natural processes and renewable resources drawn from the farm itself. That means decreasing dependency over the purchased inputs. Sustainable agriculture refers to an agricultural production and distribution system that uses natural resources efficiently, protects and renews soil fertility and the natural resource base by reducing the use of non-renewable resources like groundwater and diesel, etc. and purchase, which is external or off-farm inputs, production inputs. Optimizes the management and use of on-farm inputs, provides on adequate and dependable farm income by supporting profitable production, promotes opportunity in family farming and farm communities, and minimizes adverse impacts on health, safety, wildlife, water quality and the environment, protects environmental quality, provides consumers with affordable high quality products, decreases dependency on non-renewable resources, enhances the quality of life of farmers and rural communities, and most important, it will last for generations to come. Now, use of limited quantities of fertilizers and discrete application of small quantities of target specific pesticides at critical stages of crop damage, thereby overcoming the effects of modern agriculture. The following 7 principles will have to be kept in view to achieve success in promoting sustainable agriculture. Based on both biological potential and biological diversity, land can be classified into conservation, restoration and sustainable intensification areas. Conservation areas are rich in biological diversity and must be protected in their pristine purity. Soils with diminished biological potential, also referred to as wasteland or degraded lands, should be improved through the adoption of principles of restoration ecology, and the diversion of land suitable for sustainable farming should be prevented by legislation. Such lands should be subjected to a continuous soil health monitoring. Then the next principle is for water saving. Equity in water sharing and efficiency in water delivery and use are most important for sustainable management of available surface and groundwater resources, as water is the most important input for agriculture to be productive. The next principle is integrated system of energy management, because modern agriculture technologies are based on high energy consumption. So integrated system of energy management involving the use of renewable and non-renewable resources of energy in an appropriate manner is essential for achieving desired yield levels, so as to the system is not depending upon solely upon the non-renewable resources. Now, next principle is integrated nutrient supply system for reduction in use of market in purchased inputs and not in overall input. This means the total input needed is same, but the dependency on market purchased input should be reduced by recycling more and more waste on farm. The next principle is to maintain genetic diversity, genetic homogeneity. A characteristic of modern agricultural system only leads to greater genetic vulnerability to biotic and abiotic stress. Because when only one variety or one cultivar is used or being grown on a large area, it is vulnerable to biotic and abiotic stresses more. So diversity of crops and crop varieties will help enhance the yield stability. The control of weeds, insect pests and pathogen is one of the most challenging jobs in agriculture. Therefore, an integrated pest management system needs adoption. The conservation and wise use of genetic diversity is essential for breeding strains possessing multiple resistance to biotic and abiotic stresses. Similarly, the conservation of natural enemies of pests is important for minimizing the use of chemical pesticide and for avoiding the multiplication of insecticide resistant pests, which develops in pests after continuous use of a certain insecticide or pesticide. Whole plant utilization methods and preparation of value added products from the available agricultural biomass are important both for like farmyard manure and vermicompost are important both for enhancing income and for ensuring good nutritional and consumer acceptable properties. Now, these are the elements of sustainability. Soil conservation, reduced tillage, contour bunding, graded bunding, strip cropping, cover crops, vegetative barriers. Next is crop diversity. As we talked earlier, greater variety of crops on farm help reduce biotic, weather and market risk. Nutrient management, which include proper use of nitrogen and other nutrients, improve soil health and protect improvement. Integrated pest management, sustainable approach to manage pests by combining biological, cultural, physical and chemical methods. Cover crops means growing plants like sun hemp or horse gram in off season after harvesting a crop can provide several benefits like erosion control, soil health and weed control. Next is rotational grazing. You keep animals to graze on certain land for a period of time, and then you cultivate that land and leave animals on next land for grazing. Water conservation, deploying mulching, micro irrigation to protect quality of surface and groundwater. Agroforestry helps conserve soil and water, and marketing includes direct marketing as a way to enhance profit. And now our current concept of agriculture is, like we all discussed, is achieving high agricultural production through low input methods and skill management of those inputs. Then comes the term external input sustainable agriculture, called LISA, also called low input sustainable agriculture, or just external input agriculture, called LIA. LISA means minimal use of external production inputs, opposite to which is high external input agriculture, called HIA. There is limited access of most farmers to artificial or purchased external inputs. There are ecological and social threats of green revolution technologies and the danger of production system based on non-renewable energy sources. LISA is an option which is feasible for a large number of farmers and which can complement other forms of agriculture production. LISA refers to those forms of agriculture that seek to optimize the use of locally available resources by combining the different components of the farm system, that is plant, animal, soil, water, climate and people, so that they complement each other and have the greatest possible synergistic effects. Seek ways of using external inputs only to the extent that they are needed to provide elements that are deficient in the ecosystem and to enhance available biological, physical and human resources. In using external inputs, attention is given mainly to maximum recycling and minimum detrimental effect on environment. LISA does not aim at maximum production of short duration, but rather at a stable and adequate production level over the long term, which is the basic principle of sustainable agriculture. LISA seeks to maintain and, where possible, enhance the natural resources and make maximum use of natural processes. Where part of production is marketed, opportunities are sought to regain the nutrients brought to the market. The low input technologies include reduced use of synthetic chemical inputs, biological pest control, soil and water conservation practices, use of animal and green manures, biotechnology, crop rotations, use of organic waste, crop livestock diversification, mechanical cultivation and naturally occurring processes. Now, judging an agriculture production system to be sustainable, how can we judge an agriculture production system if it is sustainable or not? So it should be ecologically sound, economically viable, socially just, humane and adaptive. These are the goals. The methods of judging an agriculture production system to be sustainable is actually the goals of sustainable agriculture: to be ecologically sound, economically viable, socially just, humane and adaptable. And to adapt and to achieve those goals, we have to be specific in the goal categories and how to reach those goals. Like to achieve ecological soundness, we should focus on ecosystem function conservation, natural resource conservation and production capacity, whole well-being of animals and humans, environmental conservation and improvement, and harmony with nature. Similarly, when we talk about social goals like social responsibility, we should talk about acceptability of the system, cultural preservation within the system, equity and justice and fairness among farmers, fulfillment of human needs, good working conditions, human health, nourishment of humans, quality of life and strong communities. These are the low input methods and skill management to achieve sustainable agriculture by as we talked earlier, reduced use of synthetic chemical inputs, biological pest control. These can be divided into three parts, like productive and profitable. To be productive and profitable, to conserve resources and protect the environment, and to enhance the health and safety of humans. The concept of sustainability is an important element in the development of integrated systems. Developing countries around the world are promoting sustainable development through sustainable agricultural practices, which will help them in addressing socio-economic as well as environmental issues simultaneously. Within the broad concept of sustainable agriculture, integrated farming systems hold a special position, as in this system nothing is wasted, and the byproduct of one system or one component become the input for other component. Sustainable development in agriculture must include integrated farming system with efficient soil, water, crop and pest management practices which are environmentally friendly and cost effective. Now it was to judge a system to be sustainable. Now we have to talk about indices of sustainability so that we can quantify the system if it is sustainable or not. To how to quantify a system. Indices may be simple, involving one parameter, or complex, involving several parameters. Although general principles may be the same, the indices must be fine-tuned and adapted to local situations. The first one is productivity. Simple. Production per unit of resource used can be assessed by P. Productivity is equal to production by resource use. It can be any resource used. It can be land, it can be water, can be nutrient or anything. Any input or any resource used in for producing something, we can calculate the productivity per unit of that resource. The next is total factor productivity. It is defined as productivity per unit cost of all factors involved. In productivity, we were talking about one resource, and when we talk about total factor productivity, we consider unit cost of all factors involved. It was given by Hurt in 1993. Total factor productivity is production divided by resource used and cost. And summation of all the n number of resources are used, then production divided by first resource and its cost multiplied by plus production divided by second resource and its cost plus third resource and its cost. Production is total production, R is resource used, and C is the cost of resource, and N is the number of resources used in achieving total production. Third one is index of sustainability. It is a measure of sustainability relating productivity to change in soil and environmental characteristic, to know whether it is diminishing or restoring. It was given by Lal in 1993 and Lal and Minard in 1993. Index of sustainability is equal to Pi into Si into Wi into Ci multiplied by T, where Si is alteration in soil properties, Wi is alteration in water resources and quality, Ci is modification in climatic factors, and T is time. The last one is land use factor, which is defined as the ratio of cropping period, which is C plus fallow period F to cropping period. It was given by Okigbo in 1978. Land use factor is equal to C plus F by C, where C is cropping period and F is fallow period. The factor L is generally high for low intensity system like shifting cultivation, etc. That's all. Thank you.